want to show you another one of Flownex' nice features, and that is the console version. The console version is a version that will run without the user interface showing, and it can be used in connecting to other software or running batch modes, which is quite useful. So to demonstrate it, let's open a command window to get started, and we will move to our demo folder. Okay, to run Flownex Console, just paste the command. As you can see, it's the same as Flownex SE except with console added. If we execute it, it will open a file dialog. You can select a file and it will solve. This is typically not how we will use it. That's why it says type help for a complete list of commands, so we can just do that. And there it shows all the switches and how it is used. So you will typically say Flownex Console with the file name of the file you want to open next to it, and then some switches to say you want to do a steady state, no transient, etc. So we can just run our example project. Let's just solve its steady state and no transient simulation. Now we will see it is loading the libraries like it usually does when the user interface starts up, loading the compound components, and it will solve in the background. Steady state simulation is done, all solved. So this is a very nice way to run a simulation without opening the user interface. Typically, if you use a console version of an application, you would want some way to pass inputs to the application using text and to retrieve outputs. We've added a nice tool inside of Flownex to help to make that easy. Let me just launch Flownex to show you how this tool works. Okay, I'm going to open our demo project. This is our demo project, just a very simple pipe with a pressure boundary condition and a mass flow through the pipe. We will set up what inputs and outputs will be written and read from the text files using our text file link setup. We'll add a new configuration. Here you can see you can specify a file name for the inputs and a file name for the outputs. We'll just leave it as it is default, and this tells you when these files will be read and will be written, what to do in a steady state case, what to do in a transient case. Now we can say what input variables we want to read from the text file. Let's do the pipe length, it's 10 at the moment, and we will leave it in meters. And the output variable that we want to monitor, let's use the pressure drop, the output variable, and we'll leave it in kilopascals. So as it is at the moment, read before, write after, during steady state. So before the steady state, the length will be read from inputs.txt, and the pressure drop will be written after the steady state to results.txt. So what we will do now is quickly go and create a inputs text file for the length. Let's go into our project folder. The inputs text file and results text file is always at the root level inside our project folder. So let's make a new text document called inputs.txt, and inputs will be each on a new line. So if it's just one input, we can put 1000 in there for length. If you have more than one input specified, they will just be on new lines. So let's save it. We go back to Flownex and we will solve a steady state. We'll see this length was read from the text file, and our resulting pressure drop was written to the generated results.txt file. So from our batch mode, we can now manipulate the inputs in this input.txt file, run the console version repeatedly, and check the outputs in the results.txt file. So now I will quickly demonstrate how to do this from the command line, and typically how you would use this in batch modes. Just going to save this and close it. Now we will just pipe a value of 100 into that inputs text file. That text file can be modified however in any means from different software. The easiest to just to demonstrate how to use it from the command line. So to pipe in there, we will use the following command. And now we can run our console version. Again, just a steady state. And no transient. And it will read that new input of 100 meters from the inputs.txt file, do the simulation, and write the output to the results.txt file. So if we know now, just type the value of that results text file. And there we see the new value that was calculated for the pressure drop. We can repeat this process several times, and instead of having 100 in there, have 10 as our length, then execute Flownex again. And then we can see the results again, which we see is roughly about 10 times less, the pressure drop. Typically what you will do now is go and construct a batch file to run a batch in this fashion. This is such a batch file that I've created, and this batch file just executes Flownex Console repeatedly while changing the length. You can see first we'll put 1 meter into the inputs, then 10, then 100, then 1000, and all the results are collected into files called combined results, and the inputs are collected into combined inputs. Just run this batch file to quickly demonstrate it working. And there we see it going, solving the first time. solving now with 100 meters. And finally with 1000. And we can see our inputs that were given was 1, 10, 100 and 1000, and the results that were calculated are these pressure drops. In short, that's how to use the console. It can be used from any other software that can issue command lines, like optimizing software and other packages.